This is the 11A Honors Binomial Theorem video. It's all based off of what's called Pascal's triangle, and there's a pattern to how to build it. So you always have the ones on the outside going down. So you start with the 1 at the top, and then you go 1, 1, and then next, again, 1's on the outside, and then 1 plus 1 is 2. And then 1 on the outside. And then again, 1's on the outside. 2 plus 1 is 3. 2 plus 1 is 3. 1 on the outside. 3 plus 1 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1's on the outside. Again, 1's on the outside. And then you're just adding and putting what they are in its window. So 4 and 1 is 5. 4 and 6 is 10. 4 and 6 is 10. 4 and 1 is 5. And this pattern continues for an infinite amount of rows. So how to use it? This is what we use to expand binomials. So instead of if we have x plus 2 to the 5th for our first example, this would be like x plus 2 times x plus 2 times x plus 2 times x plus 2 times x plus 2. 5 x plus 2's multiplied by each other. And that can take us a lot of work. So instead we use Pascal's triangle, and it's to the 5th power. So I take the coefficients from that row with the 5. So I'm going to write those down. 1, 5, 10, 10, 5, and 1. Then you take your first coefficient or variable that's inside the parentheses, and you put it below each one. And these are like their own columns. Let me move this one over. And then you put the second coefficient or variable. Now, your first coefficient or variable starts to the exponent of what you're given, and then you go down by 1 to 0. The second coefficient or variable starts at 0 and then goes up. Now we're going to do each row by itself. So I need to make a little bit more space here. Let's put it over here. And I'm going to section each of these off. All right. So, and then you multiply each thing together. So let's start with the first column. 1 times x to the 5th times 2 to the 0. So 2 to the 0 is 1. 1 times x to the 5th is x to the 5th times 1 is x to the 5th. Then we have 2 to the 1 is 2. X to the 4th is x to the 4th. So that's 2x to the 4th. Times 5 would be 10x to the 4th. 2 to the 2nd is 4. So 4x cubed times 10 is 40x cubed. 2 cubed is 8. 8x squared. So 80x squared. 2 to the 4th, 2 times 2 times 2 times 2 times 2 is 16, and 16x times 5 is 80x, and then 2 to the 5th is 32, x to the 0 is 1, so 32 times 1 times 1 is 32. Now I add each of those ones up together. We have no like terms, so that is our polynomial. So x to the 5th plus 10x to the 4th plus 40x cubed plus 80x squared plus 80x plus 32. Make some room. And that's our answer. So let's try this next example. Expand 2y minus 3 to the 4th. So now we're using the coefficients from the row that ends with a 4. So 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. We're going to put each of the, we'll put our first coefficient slash variable, then our second one. And our second one is negative 3, and that's important. And then our 2y, and you want to put parentheses around it, starts to the 4th power, then goes down by 1. Oh, that should be a 1. And then our second one starts at 0 and then goes up. And we'll section those off. And I'll move this to the side, just a little bit more space. Oops. All right, good enough. So negative 3 to the 0 is 1, and then 2y to the 4th. Don't forget you have to do that 4th power to the 2 and the y. So 2 to the 4th is 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. So 16y to the 4th. And then negative 3 to the 1 is negative 3. 2y to the 3rd power, 2 times 2 is 4, 4 times 2 is 8y to the 3rd. And 8 times negative 3 would be negative 24, y to the 3rd, and then times 4 would be negative 96, y to the 3rd. Negative 3 squared is 9. 2y to the 2nd would be 4y squared. 4 times 9 is 36, and 36 times 6 would be 216 y squared. Negative 3 cubed would be negative 27, times 2 would be 54y, and this is negative 54y, and then times 4 would be negative 216y to the 1. Negative 3 to the 4th is 81, and then 2y to the 0 is 1, so 81 times 1 times 1 is 81. And if you notice, whenever we have a minus here, it's always going to be plus, minus, plus, minus, plus, minus, over and over and over. So our answer is 16y to the 4th minus 96y to the 3rd plus 216y squared minus 216y plus 81. All right, the next one is to find the coefficient of y to the 8th in the expansion, 2y plus 3. So right now our triangle only goes to the outside of 5. So we are going to need to build our Pascal's triangle to get that row 10. And then we'll find the coefficient of y to the 8th. So let's keep expanding. Our next row would be 1, 6, 15, 20, 15, 6, 1. And then keep going. We would have 1, 7, plus 6, 21, 35, 35, 21, 7, 1. And then we would have 1, 8, 28, 56, 70, 56, 28, 8, 1. Then we would have 1, 9, 36, 84, 126, 126, 84, 36, 9, 1. Then 1, 10, 45, 120, 210, 252, then 210, 120, 45, 10, 1. Alright, that's the row we need. So I'm going to write those out. 1, 10, 45, 120, 210, 252, 210, 120, 45, 10, 1. Then we would start 2y to the 10th, 2y to the 9th, 2y to the 8th. That's where we're going to stop because we only care about the coefficient of y to the 8th. And this is where our y to the 8th would be. Then it would be 3 to the 0, 3 to 1, 3 to the 2nd. So I'm just going to multiply out that row. So 3 squared is 9. And then 2 to the 8th would be 2 to the 8th is 256 times 9 and then times 45. So it's not going to fit in my little space there, but it's 103,680 y to the 8th. And since it just wants to know the coefficient, our answer would just be 103,680. All right, last example is to find the 6th term of the expansion x plus 2 to the 9th. So let's go copy down the 9th row. Copy and paste that down. And then we only care about the 6th term. So this would be the 1st term, 2nd, 3rd, 4th, 5th, 6th. So this is the one we're looking for. So I'm going to mark it. And then we would have x to the 9, 8, 7, 6, 5 to the 4th. And then our 2 would be squared, carry 4 to the 5th. So 2 to the 5th power is 32 times x to the 4th is 32x to the 4th times 126 would be 4,032 x to the 4th. And since it wants to know the 6th term, that is our answer, 4,032 x to the 4th. All right, that's all for this video.